The purpose of this video is to familiarize you with the process of adjusting side bearing preload and backlash on a differential at the same time in just a few minutes. This procedure is also done on power dividers found on the front drive axle of a tandem drive axle vehicle. We are working on an Eaton differential model RS404, and we will be following page 67 of Service Manual AXSM 0046. These are two of the four major steps in reassembling a differential. The steps in order are pinion bearing preload, pinion depth, side bearing preload, and backlash while maintaining side bearing preload. As you can see on this page from the service manual, there are only 5 steps in this process. They will get us our side bearing preload and the amount of backlash we need. The specified amount of backlash is between 6 and 18 thousandths of an inch. We want to get it set between 10 and 12 thousandths of an inch to allow for wear as the vehicle is operated, and the backlash will still be within range. Laid out on the bench are the tools we will be using to make our adjustments. We will need a dial indicator that reads to the nearest 1/1000th of an inch. It is attached with a flexible extension to a vice grip used to attach it to the differential carrier. We will also be using the black handle snap-on pry bar and a dead blow hammer. These are the only tools we will need to make our adjustments. On page 67, the service manual calls out the plain half adjuster and the flanged half adjuster. Inside of each bearing adjuster you can see the side bearings with the bearing cups being visible. The plain half adjuster is on the left side and the flanged half adjuster is on the right. It is called the flanged half adjuster because it is on the flange side of the differential case. The flange is what the ring gear is bolted or riveted to. To begin our adjustment, we are going to back out the plain half adjuster so that it is loose, so that it doesn't get in the way of our adjusting the flanged half adjuster. The service manual says to back it out far enough so that one thread is exposed on the outside of the carrier assembly. Before I begin to adjust the flanged half adjuster, I want to verify that I have backlash and end play on the differential case by moving it back and forth. Then I'm going to turn the flanged half adjuster in, or clockwise, using the pry bar. Pry down on the adjuster with a pry bar secured in an adjuster notch, and always pull down on the adjuster. If you try to pull up on it, it can easily pop up out of the carrier assembly. As I turn the adjuster in, I'm going to stop and check for backlash. We need to continue turning the adjuster in until we remove all backlash. As you rotate the ring gear, you will hear a clunking sound that is made between the ring gear and the drive pinion. It's that clunking sound that tells you that you still have backlash that needs to be taken out with the flanged half adjuster. As we are making our adjustments, we need to occasionally hit the adjuster with a dead blow hammer to make sure it's seated fully in the differential carrier. We need to continue to turn the adjuster in slowly, checking for backlash between the ring gear and drive pinion. You want to stop the adjuster with a notch at the top or at the 12 o'clock position so we can put the side bearing cap on and the keeper will fit into the notch. When we've gotten to where we no longer have any backlash, the service manual tells us to back the flanged half adjuster out counterclockwise 2 notches. Again, making sure to end up with the adjuster notch at the top. Then again, giving it a good hit with a dead blow hammer to make sure it is in place. While adjusting the flanged half adjuster, we turned it in until we had no backlash and then backed it out 2 notches. On the plain half, we turn this adjuster in until we see the bearing cup just start to rotate. When the bearing cup just starts to turn, we need to count 2 notches to the left of the 12 o'clock position. We will turn the adjuster clockwise until that second notch is straight up at the top. We need to hit the bearing adjuster with a dead blow hammer to make sure the adjuster is seated fully. If you hear a snapping sound while doing this, that tells you that the adjuster wasn't seated fully. If we have done everything correct, we should have the correct amount of backlash and preload. Now it's time to set up a dial indicator and measure backlash. Setting up the dial indicator properly is critical to getting an accurate measurement. The vice grip is clamped to the differential carrier, not the rebuilding stand. The flexible extension is set in a way so that it is not rubbing on the ring gear while we measure backlash, and it is tight enough so that the dial indicator stays in place and the needle doesn't move. Even more critical to setting up the dial indicator properly is how it's placed on the ring gear tooth. As you can see here, the dial indicator is placed at the heel or outer end of the ring gear tooth on the convex side of the tooth. The dial indicator also forms a right angle with the ring gear tooth, so it moves in and out and doesn't just slide back and forth on the ring gear tooth. To make our backlash measurement, we need to rotate the ring gear against the drive pinion, being careful not to cause the drive pinion to rotate while doing this. You will hear it make contact with the drive pinion. Zero out the dial indicator. Slowly and gently rock the ring gear back and forth, reading the amount of backlash. We are looking for repeatability in this reading, meaning if we started at 0 and measured 15 thousandths of an inch backlash, it should do that over and over. The dial indicator shows we are at 15 thousandths of an inch backlash, which is within the specifications of 6 to 18 thousandths. However, we are near the top end of that and want to aim for 10 to 12 thousandths, so we'll be readjusting our backlash. We need to decrease backlash, so we will be moving the ring gear towards the drive pinion to get to our 10 to 12 thousandths of an inch measurement. While readjusting backlash, we need to also make sure to reestablish side bearing preload. To do this, we must alternately loosen and tighten side bearing adjusters, making sure to loosen one first before tightening the other. If we back one out 2 notches, you have to tighten the other adjuster 2 notches to reestablish side bearing preload. 1 notch of an adjuster changes backlash approximately 3 thousandths of an inch. We were at 15 thousandths of an inch backlash, so we need to move the ring gear towards the drive pinion, so we will start by backing the plain half adjuster out 1 notch. By doing this, we no longer have our 2 notch preload on the side bearing, so I need to go to the flanged half adjuster and turn it in 1 notch. This will reestablish preload as well as decrease backlash. Again, we need to make sure the bearing caps are seated fully by hitting them with a dead blow hammer. After seating the adjusters, we can measure backlash again with a dial indicator. We've readjusted backlash and have our dial indicator set up, ready to take another measurement. With the dial indicator zeroed out, gently rock the ring gear back and forth, looking for the reading and repeatability. As you can see on the gauge, we are now adjusted to 10 thousandths of an inch backlash, well within specifications of 6 to 18 thousandths of an inch, and also allowing for wear of the ring gear and drive pinion teeth. For a final measurement before this differential can be returned to service, we need to measure again with the bearing caps back in place and the cap screws torqued to specification. The backlash measurement may change by putting these caps in place. If it does, we will readjust as needed. Rock the ring gear back and forth to measure backlash. As you can see by the dial indicator reading, we're still at 10 thousandths of an inch, so putting the bearing caps back on hasn't changed anything this time. The differential is now ready to be installed in the vehicle. This concludes the video on the procedure for adjusting side bearing preload and backlash.